Okay, do a quick lesson here on factoring to solve quadratic equations, and it's all based on something called the zero product property. And basically, if you've got two numbers that multiplied to be zero, then one of those two has to be zero. That's all it really means. But let's look at the steps on how we're going to solve using this property. The first thing that we do is we set the equation equal to 0. So I'm going to do that down here on this first one. I'm going to set it equal to 0. I'm going to subtract 4 from both sides. So I end up with x squared plus 3x minus 28 equals 0. That's the first step. The next step is to look for GFC, or GCF, a greatest common factor. And this one has no GCF. So I'm going to put that there to know that I remember to look for it. And then the next step is to factor the trinomial. And remember, when we factor a trinomial, we split the middle. And so I'm looking at this, look at the one that's in standard form. My A is 1, my B is 3, and my C is negative 28. I put A times C up here and B on the bottom. 1 times negative 28 is negative 28, my B is 3. So the two numbers I have that multiply to be negative 28 and add to be 3 are 7 and negative 4. So that's what I'm going to split my 3x into, 7x and negative 4x. And then minus 28 comes down and the x squared comes down. Now that I've got 4 terms, I'm going to factor by grouping. I can take an x out of this, so this is x times x plus 7. Over here, this is a negative, which means I'm going to factor out a negative, and I can take 4 out of that. Negative 4 times x gives you negative 4x. Negative 4 times positive 7 will give me a negative 28. Factor out the x plus 7, and what I'm left with is x minus 4. Okay, so that's the factor part. And then the way we solve is that we set each factor equal to 0. Okay, so this is going to be equal to 0 in this one. So I take x plus 7 equals 0 and x minus 4 equals 0. And I solve. Subtract 7 here, and I get x equals negative 7. That's one solution. And if I add 4 here, I get x equals 4. And that's the other solution. And that's how you solve by factoring. All right, so let's do a different one. Okay, that one was easy because there's a 1 in front of the x. Okay, we're going to do one where we factor, where we have something other than 1 in front of the x. First thing I need to do, remember our first rule, set the equation equal to 0. So I'm going to add 10 to both sides. So I have 3x squared minus 11x plus 10 equals 0. Second step is to look for GCF. There's really nothing that those have in common, so I'm going to put no GCF out here to remind myself that I did look. Okay, and the next thing to do is to factor. So my A is 3, my B is negative 11, and my C is 10. So A times C goes up here, 3 times 10 is 30. My B goes down here, and I need two numbers that multiply to be 30 and add to be negative 11, and that would be negative 5 and negative 6, so that's what I split my middle to. So this is minus 5x and minus 6x, and then I still have my 10 and my 3x squared. Now that I've got 4 terms, I can factor by grouping. I'm going to take an x out of this first one, and I'm left with 3x minus 5. Again, this is a minus, which means I'm taking out a negative, and I can take a 2 out of those. 2 times 3x gives me 6x. Negative 2 times the negative 5 will give me a positive 10. I factor out this factor, and then whatever's left goes in my second parentheses. And that's equal to 0. And then the last step is to take each factor and set it equal to 0. So I have 3x plus 5 equals 0. And x minus 2 equals 0. Subtract 5, and I have 3x equals negative 5. Divide both sides by 3. Oops, that should have been 3x minus 5, shouldn't it? Glad I caught that. I knew something didn't look quite right. Okay, so this is a minus 5. That means I'm adding 5 to both sides. Divide by 3, and x is 5/3. That's one of my solutions. And over here, I'm going to add 2 to both sides, and I get x equals 2. That's my second solution. Okay, so set equal to 0, look for a common factor, factor the trinomial, and then set each factor equal to 0. Now, sometimes we don't have a trinomial, okay? And I know that one of the ways that we might do this is to solve by square roots, but it's in here for a reason to remind you that you can also factor here. First thing I would do is set it equal to 0, and that's already been done. The next thing I would do is look for a GCF, and there's none, so I've already checked that. The next thing to do is to factor that, and if you'll remember, this is a difference of squares. These are both perfect squares, so if I write the roots of those, the square root of x squared is x, the square root of 9 is 3, and so when we have a difference of squares, we take those two roots, this goes at the beginning of both parentheses, this root goes at the end of both parentheses, one's plus and one's minus. So that's how you would do that by factoring. Then, of course, we set each factor equal to 0. So I have x plus 3 equals 0, and x minus 3 equals 0. I'm going to subtract 3 here, so if x equals negative 3, I'm going to add 3 here, so x equals positive 3. And those are my two solutions. Okay, so if you have a difference of squares, you can still solve it by factoring. Okay, then I have one more left. The first thing I do is to set the equation equal to 0, and that's already been done for me. The next thing I would do is look for a GCF. Oh, and this time I do. I can take 5x out of both of those. So I have 5x times x plus 6 equals 0. You look to see if you can factor. And there's really nothing left to factor. That's factored as far as it can go, so that's all I can do. And then you take each factor equal to 0. So 5x equals 0, and x plus 6 equals 0. Get the x by itself, I'm going to divide by 5. So x equals 0. That's a solution. And here I'm going to subtract 6. So x equals negative 6. And that's a solution. And that's how we go about solving quadratics by factoring.